in an exam, I would probably do this question last, even if it wasn't the last paper question on the paper, because it generally take quite a while. I'm not sure that on looking at this question initially. I'm just going through the list to make sure that you see they've missed off the 2C, so I'm going to put that on there, and that could be helpful later. Mark on the ratio. I should mark on the ratio. So A to P 3 to 1. I should write on 3 and 1 there. See, because I'm reading this, I'm thinking I'm not really sure where to start at the moment, so I'm just going through the sort of shopping list at the beginning of the question, making sure that I understand what I'm being told. So OQP on a straight line. So if I know what O to Q is and I know what O to P is, I could find out that relationship. Yeah, let's start with that, okay, and then I'll see where we can go with the AQ and QC. So O to Q is like going from O to A, isn't it? And then some fraction of the distance from between A and C. Okay, I've used M. Yeah, I suppose I could use F for fraction or something, I suppose. So O to A is simply A underlined, and A to C, you can see it's minus A plus C, but I'm going to write that as C minus A. Alright, and if I expand that bracket, I can join the A's together. Okay, so there we have it. Hope you agree with that expansion. And now if I can factorise out for the A, I'm left with 1 minus fraction of A plus MC. Well, that's the best I can do about O to Q at the moment, but I know that O to Q is in the same direction as O to P. Now O to P is a lot more promising. I think we've got more information about that. So, yeah, so I'm just going to tell the examiner what I'm up to. O to Q is the same direction, we're told, as O to P. They're a straight line. So O to P, that's like going from O to A and then 3/4 of the way along the line A to B. And we've been told, fortunately, how that's going to work. O to A is A, and 3/4 of A to B is going to be 3/4 of 2. I'll write it out in 4, and so therefore O to P is equal to A plus 3 over 2 C, isn't it? Alright, so times it by 2, which is 6 over 4, which is 3 over 2 C. Now there's obviously a relationship here, isn't there? We can see that we've got along 1A, and the relationship for OP is the same direction as for OQ. So doesn't that mean then that the OQ is probably shorter than OP, but we've got 1 minus M along A compared to 1, and we've got M compared to 3 over 2 for the C's, if we compare the OP and OQ. And that's a relationship I can use to calculate the value of M. Okay, so what I mean is that the part of the from O to Q is 1 minus M of an A, whereas the journey from O to P is A, but it's the same direction. So I can express that as a fraction, 1 minus M over 1. And that's the same fraction as M over 3 over 2, comparing the C coefficients, the values in front of the C. So here we go, 1 minus M over 1 is the same proportion as M over 3 over 2. So I've got two fractions, I can cross multiply, and I should be able to solve that for M. Okay, and if I've got M, I can find O to Q, and if I can find O to Q, I can also get, I should be able to do AQ and then QC. So I think we've broken the back of this problem. So just cross multiplying the fractions to solve for M, which means that 3 over 2 is equal to 5 over 2M, which means that M is equal to 3/5. So now that I know what M is 3/5, shall I just write out what OQ is? So O to Q is 1 minus 3/5 of an A, which is 2/5 of an A. And MC is going to be 3/5 of a C. Nice. So now we've got O to Q. I'm feeling a lot better now about this problem, which is pretty tricky, really, isn't it? O to P, of course, we've already got. In fact, I don't even know why I'm writing it down again. I'll write it down. A plus 3/2C. Right, so now let's compare how do I get from A to Q and Q to C, because that's the actual question, isn't it? Now I know where Q is, I should be able to answer this. So A to Q, well, that's like, well, we've got O to Q, so I just need to take away an A from that O to Q to get from A to Q, don't I? So let's do that. A to Q is going to be 2/5 of an A, take away 1A is going to be minus 3/5 of an A. So I'm going to write this as 3/5 of a C minus 3/5 of an A. Nope, don't know what's going on there. Come on. That's it. So, yeah, A to Q is like doing O to Q but minus the A, isn't it? Just reassuring myself. Yes, it is. So, A to Q is like doing 3/5 of a C minus 3/5 of an A. I like having the positive vector first rather than the negative one. Okay, good. Now let's write down Q to C. So Q to C will be like going from A to C but minus the A to Q. Q to C is like doing the whole journey from A to C, which we know, minus the A to Q bit. Yeah, minus A to Q. Leaves me with Q to C. Okay, and A to C, of course, is C minus A. I'm going to take away the A to Q, which we've already written down. And if I tidy that up nicely, you've got C minus 3/5 of a C is 2/5 of a C. And minus A plus 3/5 of an A is 2/5 of an A, minus 2/5 of an A. So it does look like we've got a 3/5 to 2/5 ratio going on. And if that's the case, that looks like it can be simplified as a 3 to 2 relationship. Now, you can see A to Q is 3/5 and Q to C is 2/5. And of course, now it dawns on me I didn't actually need to do all that work. Once I've worked out 3/5, I should have worked out the other bit would be 2/5. But never mind, did it anyway. And of course, it looks like the correct answer says there, so 3 to 2. So I'm quite pleased, although that did take me, well, that's taken me a good 9 minutes. And it's not a 9-mark question. So that will suggest I need a bit more practice on my vectors. Okay, let's have a quick look at the mark scheme. Well, I'd be interested to see what it says about the the method, particularly Yeah, I can see I did a bit of overkill on the end there. I didn't need to do quite that much work, but still, I'm happy with my solution.